today I think this is gonna be the last section that we cover for this class, and then on Thursday and Friday I'll have a review, and then Monday and Tuesday of next week we'll have the 9 weeks, and then the Monday and Tuesday of next week I might make that a makeup day. I think that's the plan. So let's go over this. Section 10.3 is simplifying radical expressions. So it's more of the same thing. Well, on the other one, you were learning the skills, some of the skills needed to simplify radical expressions, because there's more than just 10.3. We're going to do more when we come back from the break. But this is some of the rules, product rule for radicals. So when they're multiplying like this and they have the same index, the same root, so very important that they need to have the same root. In this case it's n. You can actually put them together. Either have the same root, so the root would go there, and then these two numbers would go inside. And you can move from here to here and from here to here, depending on what's better for that question, particular question. Same thing with quotient rule over radicals. Quotient means division, remember guys? So if you notice that they wrote it this one different, they have it together first, A over B. So both of these numbers or variable have the same index, which is n. You can actually separate them into individual radicals. So square root of and root of a and the nth root of b. Again, you can move back and forth depending on the situation, what's better. So today let's work on this using those rules. So again, you have the radical here. When it doesn't show, remember guys, it's a 2 when it doesn't show. So what does that mean? That in order to simplify these, they want us to multiply it. We can put them together inside. I'm gonna put it a different color. Let you guys see. I'm gonna put pink. 3 times 5. And that gives us square root of 15. Okay, once you get to that step, you need to see if you can simplify further. Obviously you can, because it was already 3 and 5. That was the prime factorization of 15, so you know those cannot be, there's no square root for those numbers, so that's the answer. Okay, the same thing. So look at the index. Are they the same when you're multiplying? Can they be simplified from the start? Square root of 21, it doesn't have any. Square root of 8 doesn't have any. So we need to still multiply, and so they have the same root, so you are able to put them together. So I'm gonna leave it blank. You know it's already, you know it's a 2 when it's blank. And then you're gonna have inside, you're gonna have 21 times x. And then from there, well, obviously for this one you can't simplify further, so that's the answer. Okay, let's do that one. So again, look at the index. Are they the same? Yes. So put them together, because you can simplify them, or you can find the roots of these things. The cube root of 4, there's none. Cube root of 2, there's none. In this case, you'll see that when you put them together, you are able to do an extra step. So they have the same index, that goes there, and then you can put them together according to the rule 4 times 2. And that will give you 4 times 2 is 8. So now if you see together the cube root of 8, so a number where you multiply 3 times, that would give you 8, that would be 2. 2 times 2 times 2 is 8. So that means the answer for this one will be 2. So yeah, sometimes you are able to simplify at the end. So let's do this one. D. So again, they have the same root, so just put them together. So 5y squared times 2x cubed and then multiply them. 5 times 2 would give you 10, and then y square, and then the x cube. And then ask yourself, is there a 4 root of 10? No. So a number that you multiply 4 times that would give you 10, there's none. Can you simplify? Yeah, you could simplify this, but these questions are not asking for that. You could do 1, 2, 4 would be 1/2, but then this one would be a separate radical, so we don't want that. We want them inside. And then this one you can. So these numbers cannot be divided by 4. Remember, you can make these into a rational exponent and then simplify it further. But 2 over 4 would just doesn't make any difference. 3 over 4, it would just complicate things. So that would be the answer. So now this one, quotients, fractions, rational numbers inside the radicals, they have the same root, so you are able to put them together. So you would have 2 over a times b over 3. And then, so you multiply across, 2 times b would be 2b, a times 3 would be 3a. And that would be the answer for this one. There's no square root of 2 or b or 3 or a, so that would be the answer. Okay, let's move on to example 2. So we're gonna apply the other rule for where you can now use this one, because I see most of them are just rational numbers. Okay, so for this one, I think it's better to go the other way, to separate them. So let's do that. And you don't have to do this once you feel comfortable knowing what's happening. You don't have to do it, but I'm not doing it for this one. So they have the same. So that root applies to these two. So that means you can separate them. Square root of 25 over square root of 49. So now it's easier to see what the square root of 25. 5, what the square root of 49? That's 7. And you can't simplify this further, so that's the answer. Okay, this one, again, they have the same root, so you can separate them. Square root of x and square root of 9. Square root of x, you can't do nothing with it, so that one stays. Over square root of 9, that one does have a square root. It would be 3, right? So that's the answer for this one. Okay, C, again, they have the same rule applies to both, so let's separate them again. Over the cube root of 27. So now find the cube root. So a number that multiply 3 times that gives you a would be 2. So 2, number that you multiply 3 times that gives you 27 would be 3. 3 times 3, 9 times 3, 27. So that would be the answer for that one. Okay, that one has more stuff over here, but let's do the same. So 4 root of 3 first, over the 4 root of 60y to the 4th. As you can tell, 4 root of 3 doesn't exist, for the top part would just would stay the same. The bottom part does have 4 roots, so the 4 root of 16, so a number that you multiply 4 times that gives you 16 would be 2. 2 times 2, 4 times 2, 8 times 2, 16. So 2. And then the letter, so the letter has a 4 over here. Remember, you can convert this into a rational exponent, so you would have y 4 divided by the index. Remember, that's the index. Maybe I should make it this color. So 4 on top and then this on top. That's why you learned that skill from the previous lesson. So the top stays the same. So this we have a 2. So what 4 over 4 would be 1. So just one, just the y. And that's the answer for that one. Okay, example 3. These ones are not easily seen how you can simplify 50. So that's the square root of 50. So for these ones, you're gonna have to split them, or find the prime factor. I'm just gonna write split numbers into something that has the roots being asked. Okay, so for example, the 50, there's no square root of 50, but we can actually split this 50 into two things. So, and we've done this before, we did it on the other section. So 50 can actually be expressed as 25 times 2. 25 times 2 is 50. And you know that 25 has a perfect square root. That's why I picked 25. You could have picked 5 times 10, but neither 5 nor 10 have perfect square roots. But 25 does. That's why I picked it. So now you can apply those rules that I just showed you. You can go backward and separate them like that. So there's a 25 here and there's a 2. So what's the square root of 25? It would be 5. And then square root of 2, it has none, so that one stays. So that would be the answer for A. Now B. So again, think about something that you can do to this number where you would have a cube root. And I can think of something really quick. I think it's, so let me rewrite it. So that one has a 3 here as the index, the root. That one I know it's 8 times 3. It's also 6 times 4, but I'm thinking about the cube root. 6 doesn't have a cube root, 4 doesn't have a cube root, but 8 times 3 also gives you 24, and 8 does have a cube root. So now let's separate them. 8 times 3. So cube root of 8 would be 2, right? 2 times 2 times 2 gives you 8. And then that one doesn't have anything, so that one stays. And that's the answer for that one. So let's move on to example 20. C, I mean. So C, if you think about it, you can do what? 2 times 13, but you're talking about square root. So square root of 2 doesn't have, square root of 13 doesn't have anything. The only perfect roots below this one that could give you this number would be 4, but 26 not divided by 4. What else? 16 cannot be divided by 26, cannot be divided by 16. 9 would be another one, and 5, which is 25. So none of them work. So for this one, you would just leave it like that because it cannot be simplified further. So that's it for that one. So this is the largest. So let's do 4 root. This is a 4. 4 root of 34. I think that one would be. So think of something that has a 4 roots. Maybe I should look for a chart. So for now, let's do this one. So 4 root of. So 32 would be 16 times 2 gives you 32. And then which of these two numbers has a fourth root? The 16. So 2, so like, let's put it here, 2 times 2 times 2 times 2 gives you 16. So that's the fourth root. These four numbers, 4 times gives you that number. So let's separate them, let's do the steps. So 4 root of 16 times 4 root of 2. So 4 root of 16 we know it's 2, and that one doesn't have any. So that one stays like that. And that would be the answer for that one. So example 4. So now these examples have letters, numbers a little bit more involved. But let's do them. So for this one, if you guys notice, this is asking for the square root of this. So now we're also splitting. So I'm gonna put it here, split maybe the numbers and the letters, so the variables. So now we're gonna think about the numbers. So square root of 25, so you know 25 does have a square root. But square root of x to the third, so you know that's a 2. And 3 is not divisible by 2, so this is where I say that you need to split this stuff. So let's do that. So that would be the square root of, you know 25 has one, so I'm just gonna leave it. That one you can split it into something that can be, that doesn't have a square root. So the x squared times x. So what did I do? X squared times x. If you apply the rule of exponents, product rule of exponents, x squared times x gives you x cubed, because that one has a 1 here. So when you multiply and they have the same base, you add the exponent. So 2 plus 1 gives you that 3, or that we had originally. So all I'm doing is I'm splitting this so that one of them does have a square root. So now let's separate them so that you see what I mean. So square root of 25 times the square root of x squared times the square root of x. Square root of 25 would be 5. So this one, remember, that's a 2, so that one we can put it into, make it look like a rational exponent. So the 2 goes on top, and then that 2 goes on the bottom. So this would be 2 over 2, and then the square root of x just stays because it doesn't have any. So let's rewrite this. So this is 5. So 2 over 2 would be 1. So this is just an x. And then you have this stuff here. And that's all you can do. That's the answer for this one. Okay, now let's do that one. So that one, again, you can split the numbers and the letters. So this one, so look at the letters. So the other one has a 6. 6, is it divisible by 3? Yes. So we don't have to do anything with that one. About 8, can we split this one so that we get something that has a cube root? I think, yes, we can. So how about the number? Is there a cube root of 54? There's none. So again, this one we're gonna have to split it too. We're gonna have to factor it out. Also, that's another word, prime factor, where we're not gonna go all the way to a prime factorization of numbers. This is just what we need. So that's a 3 here. So this 54, I'm gonna make it into a 27 times 2. So 27 times 2 gives me 54. X to the 6, since I know 6 can be divided by 3, I'm gonna leave that alone. Y to the 8 cannot be divided by 3, but I can split this one. I'm gonna put that one, I'm splitting. So I'm gonna put y to the 6 times y to the 2. So y6 times y2 gives you 6 plus 2 gives you that 8. Okay, now let's do them individually. We're gonna have a bunch of stuff here, but I'm doing this so that it's understandable for you guys. Times, so cube root of 27, and then you have the cube root of 2, and then you have the cube roots of x to the 6, and then you have the cube roots of y to the 6, and then you have the cube roots of y square right there. So I just apply that rule, the product rule for radicals. So cube root of 27, that would be, put it here, 3 times 3 times 3 gives you 27. So that would be 3 for this one. Cube root of that doesn't have any. And then at the end, we're going to combine the stuff that doesn't have any. And then times this one, remember you guys can put it as 6, the exponent on top, and then the root on the bottom, 3. And then this one, the same thing, 6 on top, and then the root at the bottom. And then that one stays the same, because you can't find the cube root of y square. So now let's simplify. So that one's already good. So 3, I'm gonna do this one, 6 over 3, so that would be x squared, and then this one, 6 over 3 would be y squared, and then you have these two things times, and I'm just doing a bunch of extra steps so that you see what happened. So here we can actually combine these two because we can't do nothing with them. We can put them together because they have the same index. So we can rewrite this finally as the final answer for this one would be 2y squared. And that would be the final answer for that one. That's 4. Let me see what they have. Yes, that's what they have. So the same thing here, guys. Find, so the root of 81. So you need to ask yourself, does 81 has 4 roots? And let me see, it does. So this one we don't have to split it. This one is 11 divisible by 4. It's not. So that one we're gonna have to split. So I'm gonna put that split sign right there. So let's rewrite them as 4th. So that one's gonna stay the same because we know it has a 4 root. This one we're gonna split into, I think 8 times c to the 3rd. So 8 plus 3 gives you that 11, same base. So I'm just applying the product rule, going backwards basically. So now let's separate them. The 4 root of 81, the 4 root of z to the 8th, and the 4 root of z to the 3rd power. So I split that one. That one means I split it. So the 4 root of 81 would be 3. So let's put a note here really quick. So 3 times 3 times 3 times 3, 4 times gives you 81. So we know the answer for that one is 3. So that one again is the c, so the power goes on top, divided by the 4 on the index. And then that one stays because we can't do nothing. 3 cannot be divided by 4. So that one stays. So that would be 3. 8 over 4 would be z squared. And then that would be 4z 3. That's the answer for that one. Alright, let's move. So 3 more examples. So this one is the same thing as this. It's just a lot of stuff going on. So again, you're still thinking about splitting stuff, factoring, prime factoring stuff partially, the numbers and letters and variables. Letters, okay. So the square root. So does 20 have a square root? Can we? No, it doesn't. So can we find something that does? So we know 4 is a perfect square root. We know 9. So 20 can be divided by 4. So we're gonna split this. So I'm gonna put we're splitting it into 4 times 5 gives you 20. The 5 doesn't have something that we can't, so we're just gonna leave it alone for now. So 5, and then we separate the top, so I'm gonna continue here. So square root of 4 times square root of 5 over the square root of 5. And this is gonna work beautiful if you guys notice, because look, that you're gonna apply what we learned on the previous lesson, where you can simplify, right, vertically. So square root of 5 over square root of 5, that becomes a 1. These things become a 1. We don't have them anymore. Square root of 4 would be 2. That's the answer. Okay, now this one's, so 50x. So square root of, so the x, it's not gonna work, but we can find a perfect root here. We're gonna split 50, and then that one we're gonna leave it alone, so I don't think we can do anything with it. So let's do this. So put square root of 250. We're gonna do 25 times 2 gives you 50, and we know 25 has a perfect square root. And then the x doesn't, so we're just gonna leave it there. So separate them. Square root of 25, square root of 2x. I'm gonna leave 2x inside here because we can't do nothing with it. Usually I would separate them, but I'm just gonna leave it like that to save time. And then divided by, and then that one's gonna stay the same. 2 square root of 2. So now let's simplify. So square root of 25 would be 2, and then this one stays there for now, 2x, and then at the bottom we have, and this is not a 2, I don't know why I said 2, square root of 25 is 5, and then we have excited, and then we have the 2 here. I got confused with that. So this is where we're going from here. So we're going to make this. So now that one, we still have that square root of 2. You know what? I should have separated them because it was going to work perfectly. If you notice, you can actually cancel this. So I'm going to separate these anyways because it does help. So 5 times square root of 2 times square root of x. So I just split this one using the rule. And then 2 square root of 2. So if you notice, these two are the same. So you can eliminate that. So the answer would be 5 over 2 square root of x. Or you can put it on top with the 5, doesn't matter, or like this. That's the answer. Okay, that one I'm gonna leave it for you guys. It's more of the same, it's just more work. Thank you.